This lesson discusses permutations and combinations. Don't let the names scare you. They're very simple concepts once you get the hang of it. Now, there are some notation issues that I do want to point out to you. I'm not exactly sure why this book chose to write the symbol for permutation this way. The majority of the time, you see it written this way. And we would normally say we are taking a permutation of n items taken r at a time. In other words, n represents the number of items you're choosing from, and r will be the number of items that you choose. Now, the concept here is when we're working with a permutation, order matters. And as we go through some of these examples, I think you will see better illustrated what I mean when I say that order matters. And the formula that we use for finding a permutation is located right here. Now, you might not be familiar with this symbol. It's not an exclamation point as in we have a really excited N. Instead, this is called factorial. N factorial. And what that simply means is that we would take all the numbers from n and count our way down until we get to 1, and then we would multiply them together. So for example, if we had 4 factorial, that means you multiply 4 times 3 times 2 times 1. That's all a factorial is. It's a shortcut way of showing you that you're going to start with that number and multiply by every integer value, counting down by 1 until you get to the number 1. Now, the difference between the permutation and the combination is in a combination, order doesn't matter. Order doesn't matter. Now, if you're thinking for a second about possibly years ago when you were in school and you might have had a locker and there was a lock on there, when you were given a combination to the lock, did order matter? Actually, it did. If you were supposed to go to the right 3 and to the left 18 and back to the right 2, then you would not get your locker to open if you did those in a different order. Technically, it probably would have made more sense to call it a permutation lock instead of a combination lock, but for whatever reason, it's called a combination lock. You just have to remember in a permutation, order does matter. Combination, order does not matter. And if you compare these two formulas, here's what you will see is the only real difference. They look identical other than in a combination we have an additional r factorial in the denominator. And that's because if order doesn't matter, we're going to need to divide out all of the extra things when they got counted more than once. For example, if you were looking at the number of ways that you could pick people to serve on as officers for a club, and you're going to elect a president, a vice president, and a secretary. And the way you're going to do it is the person with the most votes gets president, second most is vice president, third most is secretary. Would order matter when you're selecting those officers? Absolutely. Okay? Because if I'm going to have the person with the most votes end up being president, I could have the same 3 people, but if the votes changed to where instead of Ted having the most votes, maybe Fred gets the most votes, I then have a different set of officers. It could be the same 3 people, but if they change offices, it's a different set. That's a permutation. But on the other hand, if I just wanted to put together a committee of 3 people, would Ted, Fred, and George be a different committee than if I had George, Fred, and Ted? That's the same committee. The order I write their names down in would not matter. So what we have to do is divide out the extra times that those were being counted from the permutation. Now, we talked a little bit about this notation here, and here's what I want you to see is if you want to solve this, a permutation of 7 things being taken 3 at a time, you may use the formula up here, which would mean that you would take 7 factorial and you would divide that by 7 minus 3 factorial, which means I have 7 factorial divided by 4 factorial. Now, you can work that out on paper. You can put it in a calculator, and most calculators will have a factorial button. If you're working with the TI calculator, the TI 83 or 84 calculator, if you go into the math function and you go to PRB, which would be the last column across the top after you've hit math, you will see that factorial button there. So you can use that. But if you're paying attention, you're also going to see this, and you would see the combination as well. So you're going to have the P in R like this. You're also going to see it when it's the combination. Now, to enter it into the calculator, if you want to use this feature, you have to first type in. So you would type in whatever value n is first, then go to math, PRB, and then you would choose, if you're doing the permutation, you would choose this button. Okay. Then enter whatever value R is. So in our case, you would type 7, go to the math button, arrow over to PRB, choose the one for permutations, and then you would put in the 3. And what you should end up with when this is all simplified would be 210. Let's go to the next problem for a little more practice. So you can either use the formula, write it out manually, which would be 8 factorial divided by 8 minus 5 factorial. And you could simplify it that way, or if you go to your calculator, you would type 8, then type math, arrow over to probability, choose number 2 for your permutation, and then type in 5. And what you should get back is 6,720. So there would be 6,720 ways that you can choose 5 things when you're picking from 8 things. So in other words, there's 6,720 different groups of 5 that I could choose from that. And within these groups, order would matter. There's a difference between which one's number 1 and which one's number 5. Okay? Now, just to show you a comparison, if it's a combination and we take out those things where the group is the same, but because it was in a different order, they got counted separately in permutations, and we don't want to do that with combinations, then you could type 7, go to math, arrow over to probability. This time choose number 3 for combination and enter in 3, and you're going to find out that's only 35. We had 210 different ways we could choose 3 at a time if it's a permutation, and order matters. In other words, if we were picking, say, 3 different officers for some club, because order would matter if they're officers. But if we were looking for a committee, there would only be 35 different committees that we could put together. Same thing on a combination of 8 things taken 5 at a time. If you put that into your calculator and you simplify, you're only going to come up with 56. Notice we had 6,720 when it was a permutation. That went all the way down to 56 when it was a combination. Now, part of what you need to do or be able to do is to determine whether something is a permutation or a combination when you read the scenario, because in the real world, you're not going to see the word permutation or the word combination. You have to figure that out. So if you have the number of ways 8 people can stand in a line for tickets. Now think about that. That's saying if I've got 8 people, how many different ways can those people be standing in line? And ultimately the question you're asking yourself is, will it make a difference if I change the order? If Tom is the first person in line and I decide I'm going to switch him with the person who's number 8, do you think Tom is going to care? Yes, I think he will, especially if it's a first come, first serve. They're trying to buy tickets, and if 7 people go before him and they buy all the tickets up, he's out of luck. That means this is a permutation. Order matters. Now, if you look at the next one, the number of ways letters can be assigned for a car license plate. Do you think order matters on a license plate? If you have CJR as the first 3 letters on your license plate, does that make it different from somebody whose license plate has an R and then a C and then a J? Yeah, those are going to be different. Order matters. That's a permutation. Now, number 9, the number of ways students can be chosen to serve on a committee. Okay, ask yourself, if it's a committee, does order matter when I put those names down? And hopefully you've already understood from what we've talked about before, no, order doesn't matter. That makes this one a combination. How about the number of ways students can be assigned offices on a committee? So now, not only are you on the committee, but you're going to have officers on the committee. So will it make a difference? Will order matter when you're talking about filling offices? Hopefully you recognize, yes, order matters. That's what turns it into a permutation. And let's go to the next slide. Okay, and let's look at one more. We're going to skip number 12, but we can look at number 11. The number of ways a 5-card hand can be dealt from a standard deck of cards. So think about that for a minute. If someone is dealing out 5 cards for a hand, does order matter? Does it make a difference which card you pick up first and which card you pick up last if you're going to end up with all 5 cards in your hand? Will order matter? The answer is no. That's going to make this a combination. And I think we've done enough of those. So let's skip number 12, go to number 13. In a mathematics club, 6 people are running for the offices of president, vice president, and then the third office is secretary, treasurer. The student with the most votes will be president. Student with the next highest would be vice president. Third highest gets the third office. How many ways can the offices be filled? Now, this is not just asking me to identify whether it's a permutation or combination, but in addition to identifying that, I have to solve it. So how many people are involved here. We have 6 people running for office, and how many offices will be chosen? Well, we have president, there's 1, vice president, there's 2, and then secretary treasurer is a combination office. There are 3 that will be chosen. And since it's going to be selected to where the person with the most votes is president, second most is vice president, and so on, will order matter? The answer is yes. So that makes this a permutation. We are choosing from how many students? 6. There are 6 running for these offices. How many are going to be chosen? And the answer to that is 3. So it's a permutation of 6 things taken 3 at a time. So again, if you want to go to your calculator, you would choose 6, and then you would go to math, arrow over to probability, and then you can select number 2, which is going to be a permutation of n things taken r at a time. And if I simplify this out, this would be 6 factorial over 3 factorial, which means I'm multiplying 6 times 5 times 4 times 3 times 2 times 1 over 3 times 2 times 1. This is what it's going to look like if you did it without the calculator. Whichever way you choose, you should still come up with 120 for your answer. That's how many ways the offices could be filled. Now, look at the next question. How many ways can 10 people line up in a cafeteria line? Okay, now think about it. If you're standing in a cafeteria line, and there are 10 of you, is order going to matter? And again, yes, I mean, whoever's first in line will get food before the person who is last. So that makes it a permutation. How many people will there be in the line? 10. And how many different ways can somebody be in the first position? How many are we going to end up choosing? Every group is going to have how many in it? It's going to have 10 in it. It's a permutation of 10 things taken 10 at a time. We just want to know if there are 10 people there, what are going to be the different ways they could line up. So, if we went to the calculator and we did a permutation of 10 things taken 10 at a time, think about that for a minute. That's 10 factorial over 10 minus 10 factorial. Well, 10 minus 10 is 0. And remember, by definition, 0 factorial is equal to 1. So I have to take 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. There are 3,628,800 different ways. Wow, that is a lot. Okay, now here's another one. How many ways can 6 people be chosen from a group of 12 to attend a conference? Now, if there's going to be 6 people chosen to attend a conference, will order matter on how their names are listed on the registration form? No, it really won't. Those are just going to be the 6 people who are going. That means this has got to be a combination. We are choosing from 12 people. That means our N is 12. How many will we choose? 6. So it's a combination of 12 things taken 6 at a time. You work that out either by hand or in the calculator, and you get 924. There's 924 ways that you could pick 6 people out of that group. All right, last example. In a lottery game where 4 numbers are chosen from the set of numbers from 0 to 9, how many different 4-number cards could be made where, first of all, order is taken into consideration? Now, if order is taken into consideration, does that mean order matters? The answer is yes. And when order matters, which is it, a permutation or a combination? It's a permutation. That's when order matters. We have to know how many numbers we are choosing from. And if you count up in that list, there are 10 different digits there. And how many are we going to choose? 4. So it's a permutation of 10 things taken 4 at a time. If you simplify that, you should get 5,040. There would be 5,040 different number cards that you could make. Okay? And the reason order is going to matter, first of all, it told us order would be taken into consideration. But that's because these numbers are going to be different numbers. If I'm looking at the digits 3, 5, 7, 2, that's a different number from 2, 7, 3, 5. Okay? So order matters. Now, if order didn't matter, and maybe it was something like the way the lottery is done when they call out the numbers on Saturday night or whenever it is, you just have to have those numbers. They don't have to be in any particular order as long as those are the numbers on your card. And so if order doesn't matter, that's a combination. And if it's a combination of 10 numbers taken 4 at a time, you can put that into the calculator and you discover that there's 210 different ways that can happen.